In this presentation on the digital thread, Origin shows how it helps QA automate manual tasks and deliver more value to manufacturing. In the next 10 minutes, this video will give you a brief profile of Origin and how it comes to be a leader in the digital thread. We'll look at the workflow from several different perspectives to see how and where the digital thread improves things. And we'll show examples of the unique digital thread features and benefits of Checkmate for SolidWorks. So let's go to step one, which is a little bit of the story of Origin. We make the Checkmate add-in for SolidWorks. It's a set of unique tools that engineers use to solve dimensional problems in automotive, aerospace and defense, medical devices, and oil and gas. We've been doing this for the better part of 25 years. Second, let's consider the workflow. People tend to think of this as a one-way flow from design downstream through manufacturing to inspection. Today, though, we're flipping the script and we're starting with inspection and working upstream through manufacturing to design. The reason that we did this is that dimensional problems tend to get blamed on QA. And while at times parts can't ship because QA is struggling to keep up, there are also times that dimensional problems that QA discovers originated someplace else. The real issue is that product manufacturing information, or PMI, needs to move freely among design, manufacturing, and inspection, and it doesn't. When I say PMI, I'm using it in the broad sense of the annotations that go on the CAD and the inspection results that come back from inspection devices like scanners and CMMs. There are many ways the flow is constrained. For instance, computers have to wait for people to translate the PMI into a form the computer can understand and then input it into the computer system before the computer can do its job. MBD really removes the constraints because it's PMI that computers can read and people can read too. So manual processes can be automated and done well. MBD pays for itself and reduces scrap and rework as well. If you visit QA or you work there, you're probably familiar with these manual processes that are needed to consume PMI. It takes a lot of expertise and time, which really brings me to the third part of our demo, which focuses on the cast machining process, and in particular this pump housing, cast pump housing, prior to machining. In a moment, my colleague Cecil DeLine is going to show you how this works in Checkmate in 3 different ways. First, he's going to show you how you can reuse PMI from design and from inspection devices such as scanners and CMMs, and work with those results directly inside SolidWorks. Second, he's going to show you how Checkmate automates reporting and feature tracing and other tedious manual tasks. And finally, he's going to show you how Checkmate automates the setup and bookkeeping needed to simulate solutions for dimensional problems, once again, inside Checkmate for SolidWorks. Now, one bit of full disclosure. We substituted a 3D printed part for the cast blank. If we had used a cast blank, more features would have been good at this stage because the output quality of the 3D printing process was a bit lower than the output of the casting process. So to show you the workflow, the tolerances needed to be relaxed a little bit, which we've done. The workflow itself, though, is still 100% reflective of the workflow if you were working with a cast blank. So now over to you, Cecil.
Good day, everyone. I'm going to show how Origin's Checkmate for SolidWorks links inspection to the digital thread. We do this by consuming the DIM Expert MBD and driving it through the metrology and dimensional problem-solving processes. On the screen, the SolidWorks DIM Expert tree containing the MBD appears on the left. In the center of the screen, the MBD is shown graphically on the CAD. And over on the right side, you'll see Checkmate's browsers. The first you'll see in action is the programming browser. First, Checkmate processes the STL file that CMS created with a GOM scanner and extracts a color map. Next, Checkmate consumes and reuses the MBD to develop an inspection plan. At the same time, Checkmate also extracts all the actual data from the color map. In a moment, I'll show you how you use Checkmate to get value from all this data. That's just as soon as I draw your attention to all these yellow lines on the CAD. These are the measurements that Checkmate created using the MBD to construct and then extract from the GOM scan. There are hundreds of features on this part and thousands of measurement points. Why so many on a relatively simple part? It's because more complex parts are common, requiring this level of measurement, and permission to show them is very uncommon. You can burn hours moving data from the apps QA uses to the apps that manufacturing and design use. With MBD, we moved all this data from GOM to Checkmate for SolidWorks in the time that it takes to make a pot of decent coffee. And we've reused the MBD to generate all the feature nominals for the appropriate tolerances, including the balloon numbers. So when you need to generate reports, in this case, a first article inspection report, you have 100% traceability back to the DIM Expert CAD annotations, and there's no time loss to rekey numbers. Now, as Jeff said, manufacturing may need to iterate through many dimensional problem solutions to find the best fix. You're going to need a metrology expert to set up the data in their own datum reference frames and help process it. The bookkeeping for the trial scenarios is really tedious. To help out, Origin added a new utility to Checkmate. MBD annotations enable Checkmate to set up the analysis framework and populate it with all the measurements. Checkmate also gives a first cut of a best fix solution. It's the GeoTol Manager, short for Geometric Tolerancing Manager. All of the results are instantly organized into their datum reference frames. Looking at the highlighted features, the deviation column shows how much these features were out. The features are green though, so Checkmate found enough bonus tolerance in the datum structure to declare that the features are in. The browser also shows how much bonus tolerance was used. We'll have more to show about the GT Manager on our next webinar with CMS. Back to you, Jeff.
Thank you, Cecil. That was great. Let's review the 3 key takeaways from Cecil's demo. First of all, with Checkmate, you can reuse the full spectrum of product manufacturing information, whether it's coming from CAD, scanners, or CMMs. And Checkmate automates those tedious and error-prone tasks for feature characteristic tracing, analysis, and reporting. The actual time it takes to reuse all that scanner information in this demo and the MBD was about the time it takes to make a decent pot of coffee. Without MBD, it would have been impossible to give design and manufacturing these insights into what QA is seeing. And Checkmate provides engineers with the tools they've never had to simulate best fixes to dimensional problems inside SolidWorks, which means it's much faster for manufacturing to come up with better solutions and do it with less scrap and rework. To find out more about how you can benefit from the digital thread, contact Origin at this link for a free consultation.